Hello and welcome. Here I will explain the centrifugal pump problem. So let's start. So a centrifugal pump impeller runs. Let me use the pen. Centrifugal pump impeller runs at this RPM at 1400 RPM. And Vents at angle at exit is 25 degree. This is the blade angle at exit, or beta 2. Impeller has an external diameter of 0.4 meters and an internal diameter of 0.2 meters. Assuming a constant radial flow through the impeller at 2.6 meters per second, calculate the angle made by the absolute velocity of water at exit with tangent. And second, the inlet vane angle, or the inlet blade angle, or beta 1. And third, the work done per kg of water, or the specific work. Now, let's consider the given. The RPM is 1400, and we have diameter 1, 0.2 meters, and diameter 2, 0.4 meters, diameters of the impellers. And the radial flow velocity is constant throughout. That means the inlet radial flow and the outlet radial flow is same, and it's given to be 2.6 meters per second. And the blade angle at exit, or beta 2, is given 25 degree. So the required one are alpha 2, or the flow angle at exit. This is the angle between the flow velocity and the rotor velocity at exit. And second one is beta 1, or the inlet blade angle, the angle between the relative velocity and the rotor velocity. Sorry, and the third one is the specific work. When we come to the solution, the first thing that we do, if the dimensions and the RPM is given, we can calculate the rotor velocity at inlet and outlet. In this case, U1 is the inlet rotor velocity, which is the tangential to the inner circle at that point, or at point 1. Pi d1 n over 60 is U1. From this, we get 14.67 meters per second. And U2 has pi d2 n divided by 60. And this gives 29.33. So always in centrifugal pumps, the outer tip velocity and the outer rotor tip velocity is larger than the inlet rotor velocity, because it depends on the diameter. Now, having this said, we can go directly to the velocity triangles at the inlet and outlet. Considering the blade as a backward curved blade, because alpha 2 is 25 degree, those less than 90 degree exit or outlet blades are backward curved. So directly we can understand, if the angle at the exit is 25 degree, it is backward curved blade. From that, we form this blade, we draw this blade, and we can see the velocity triangles. Now consider this inlet point to be point 1. And this is the exit, or the outlet. From this, we can directly draw the tangent to that circle at that exact location or point, to be U1. And for 2, we have this tangential which is the rotor tip velocity at that point. So when we draw U, it has to be tangential to the circles at that point. The second thing is the relative velocity, which is always projected from the tangent of the plate. Now, in the exit, we can see the tangent is at this point. The tangent is at this point. So we can draw the relative velocity having this beta 2 tangential, exactly tangential to the plate. When we come to the point for point 1, we have also this tangential at that point. We have this tangent. It means this is the sorry, this is the relative velocity at inlet. Directly, we can form the parallelogram by pulling this line to follow the U1. We can have C, the vector C, to be the rotor velocity plus the relative velocity, or W. Once we draw U, W follows and C is connected in between the beginning of U and the final point of W. Having this relation, now we can understand to form the parallelogram. Once this U1 is drawn, now W1 can be followed. W1 can be followed, and then we can connect C1. We can connect the points by C1. We have formed now alpha 1. We have formed beta 1 here. We have also the radial component, which is given vertically, and the tangential component of the C1. C1 has 2 components. Also at the outlet, we can see we have this U2, and we brought W2 from this tangential to the plate. And then we connected the points by C2. So the angle between this U and C2 is alpha 2, and the angle between U2 and W2 is beta 2. We have radial component of C2. Also, we have tangential component of C2. C2 has 2 components. The important component which is doing the job is the tangential component, or the component which is in parallel with the U2. From inlet velocity triangle, from the statement, it says the flow enters radially. That means alpha 1 is 90 degree, or the angle between the flow velocity and the rotor velocity is 90 degree. This is alpha 1, and it is the same with the radial component. C1 is equal with CR1, and CW1 is now 0. We don't have tangential component at the inlet. It is completely radial. From this, we can calculate the angle, the plate angle, by the tan relation. Tan beta 1 is therefore CR1 over U1. CR1 is 2.6 and U1 is 14.67. From this we get this value. tan inverse of that value is the angle. So we have 10.09 degree. So this was one requirement, one parameter to be calculated. Now we have done that one. From the outlet velocity triangle, the one thing to be required to be calculated is alpha 2. So alpha 2 can be found from the outlet velocity triangle. We have this U2 and we have this C2 and W2. We have resolved C2 into two components, and this component of C2 is CW2 and the vertical is C2R, and the whole one is U2, is U2, and this remaining one, this portion is U2 minus CW2. So tan alpha 2 can be related as CR2 divided by CW2, but we don't know the value of CW2. Since we have beta 2, CW2 can be found from that relation. Tan beta 2 means CR2 or C2R divided by U2 minus CW2. From that, CW2 was calculated to be 23.75 meter per second. Now we have CW2 from the beta, and tan alpha 2 is now 2.6 over 23.75. From this we get alpha 2. So problem solved. The third one is the specific work, or since specific work is given by the specific work is initially given by U2 CW2 minus U1 CW1. Now we have this component to be 0, and simply the specific work becomes CW2 multiplied by U2, and we have CW2 from this to be 26.48, and we have also the U2 to be 29.86. Now we have this value for the specific work. So from this problem, what in generally can understand is we can correlate the velocity triangles to calculate the specific work, and also the missing angles, the blade angles and the flow angles can be calculated. So this needs careful analysis, and it's interesting, and thank you.